In this video, we are going to talk about the geometric mean and arithmetic mean and relationships between them. Let us first see what is a geometric mean. If a and b are two positive numbers, then a number g, which is square root of ab, is known as geometric mean gm of the numbers a and b, which also means that the numbers a, g, b are in geometric progression, which also means that g upon a equals b upon g, or g square equals ab. For example, numbers 2, 4, 8 are in geometric progression, which also means that 4 upon 2 equals 8 upon 4, which also means that 4 square equals 8 multiplied by 2. Hello friends, you are watching YouTube channel Number Collage. This channel features easy to understand concept videos on mathematics. If a and b are two positive numbers, then let us see how we can insert as many numbers as we like between a and b, such as g1, g2, g3, so on and so forth, gn, such that the sequence a, g1, g2, g3, so on and so forth, gn, and finally b becomes a geometric sequence and hence a GP. Now if we start counting from this A, so this will be the first term, this will be second, this will be third, so on and so forth. This will be n plus 1th term, and finally B will be n plus 2th term. So we write B equals A r power n plus 1, so that r power n plus 1 will be b upon a, and hence r will be b upon a power 1 upon n plus 1. So for this geometric progression, we have common ratio r equals b upon a power 1 upon n plus 1, where a is the first term. Now we write this g1 being the second term as g1 equals ar, that will be a times b upon a power 1 upon n plus 1. This g2 being the third term, we write g2 equals ar square, that will be a times b upon a power 2 upon n plus 1. This g3 being fourth term of the GP, we write g3 equals ar cube, that will be a times b upon a power 3 upon n plus 1, so and so forth. And finally we write this gn as gn equals a times b upon a power n upon n plus 1. Now we will see how we can use this formula to insert required numbers between the two positive numbers a and b, so that this sequence will be a GP. Suppose we want to insert three numbers between 1 and 256, so that the resulting sequence becomes a GP, where this 1 is A and this 256 is B. So the sequence will look like 1, G1, G2, G3, 256 should be a GP. If we compare this with a standard GP, which is AR square, AR cube, AR power 4, it will be 1 R square, R cube, and R power 4, where this R power 4 will be 256, that we write 4 power 4, that will give us R equals plus minus 4. Now for r equals 4, g1 will be r, that is 4, g2 will be r square, that is 4 square, 16, g3 will be r cube, that is 4 cube, 64, and the GP will be 1, 4, 16, 64 and 256. And for r equals minus 4, g1 will be minus 4, g2 will be minus 4 square, that is 16, g3 will be minus 4 cube, that is minus 64, So the GP will be 1 minus 4, 16 minus 64 and finally 256. Let us insert two numbers between 3 and 81 so that the resulting sequence is a GP. Let the two numbers be G1 and G2 such that the sequence 3, G1, G2 and 81 is a GP. Comparing this GP with the standard GP, which is AR square, AR cube. Putting A equals 3, this will become 3R square, 3R cube. This comparison gives us 3R cube equals 81. So we write 3R cube equals 81. R cube equals 81 by 3, that is 27, and R equals 3. So the two numbers to be inserted, G1 will be AR, that is 3 multiplied by 3, 9, and G2 AR square, that is 3 multiplied by 3 squared, 9 threes are 27. So the numbers to be inserted will be 9 and 27 so that the sequence 3, 9, 27, 81 becomes a GP. Next, we will study the relationship between arithmetic mean AM and geometric mean GM. For two positive numbers A and B, their arithmetic mean AM is A plus B upon 2 and their geometric mean GM is square root AB, denoting arithmetic mean as A and geometric mean as G. Let us find A minus G, that will be A plus B by 2 minus square root AB. This will be A plus B minus 2 square root AB upon 2. This we write as square root of A whole square plus square root of B whole square minus 2 square root of A into square root of B upon 2. So now this A minus G becomes square root A minus square root B whole square, this expression in the numerator being a perfect square, upon 2, which is going to be positive or equal to 0 because the quantity in the numerator is a perfect square. So that gives us A greater than or equal to, bringing this G to the right hand side, G. So the relationship that we obtain here is arithmetic mean is greater than or equal to the geometric mean. So this is the relationship between arithmetic mean and geometric mean. Next problem is the sum of two numbers is 6 times their geometric mean. We have to show that the numbers are in the ratio 3 plus 2 root 2 is to 3 minus 2 root 2. We will start by assuming the two numbers to be A and B. Now the sum of these two numbers is 6 times their geometric mean. So we write A plus B sum of two numbers equals 6 times their geometric mean, which is square root of AB. Next we square equation 1 and write A plus B whole square equals 36 AB. Now we have A minus B whole square equals A square plus B square minus 2AB. This we will write as A square plus B square plus 2AB minus 4AB. Now this part is a perfect square that we write as A plus B whole square minus 4AB. But we know that A plus B whole square, which is this, is 36AB. So we write 36AB minus 4AB. That will be this A minus B whole square equals 36 minus 4, 32AB. We will take square root of this, that gives A minus B equals square root 32 multiplied by square root AB. This will be 4 square root 2 square root AB. So we have A minus B equals 4 root 2 times root AB. We name this equation 2. Now we will find the values of A and B from this equation 1 and this equation 2. So we will add these two equations. We get A plus this A will be 2A. B minus B will be 0. That equals 6 root AB plus 4 root 2 into root AB. This will be 6 plus 4 root 2 times root AB. So A will be dividing by 2. It will be 3 plus 2 root 2 square root AB. We will substitute this value of A in this equation 1. So equation 1 becomes 3 plus 2 root 2 into root AB. For this A plus B equals this 6 root AB. So that gives B equals 6 root AB minus this 3 plus 2 root 2 root AB, which will be 6 minus 3, that is 3 minus 2 root 2 times this root AB. This is the value of B. Now when we take ratio of this A is to this B, this root AB cancels from both sides and we get this ratio, which is 3 plus 2 root 2 is to 3 minus 2 root 2. If arithmetic mean AM and geometric mean GM of roots of a quadratic equation are 8 and 5 respectively, then we have to obtain the quadratic equation. Let us assume the roots of the quadratic equation be A and B. So now arithmetic mean of the roots will be A plus B upon 2, which is given to be 8, and the geometric mean will be square root of AB, which is given to be 5. Now a quadratic equation in x will be x square plus sum of roots into x plus product of roots equals 0. So that will be x square plus sum of roots, that is a plus b, times x plus product of roots will be ab, that equals 0. So the quadratic equation will be x square plus, from this we get a plus b equals 2 times 8, that is 16 into x, plus from this equation by squaring we get ab equals 25. So it will be plus 25 equals 0, and this is the required quadratic equation. Next problem is, if a and g be arithmetic mean and geometric mean respectively between two positive numbers, then we have to prove that the numbers are a plus minus square root of a plus g into a minus g. We will assume the two positive numbers to be a and b. Their arithmetic mean a will be a plus b upon 2. Therefore we get a plus b equals 2a. We name this equation 1. Next, the geometric mean g will be square root ab. Therefore ab will be g square. We know that a minus b whole square is a plus b whole square minus 4ab. So that will be, putting 2a for this a plus b, we write 2a whole square, that will be 4a square minus 4, and writing this g square for this ab, it will be minus 4 g square. So this will be 4 times a square minus g square. This is a minus b whole square. Taking square root of this, we write a minus b equals plus minus square root of 4 is 2 square root this a square minus g square. We name this equation. Now to find the values of a and b, we will add equations 1 and 2. So this a plus a will be 2a, b minus b will be 0, that equals this 2a plus minus 2 square root of a square minus g square. Cancelling this 2a from both sides, we get a equals a plus minus. Here we will factorize a square minus g square as a plus b into a minus b. Now we will use this value of a in equation 1 to find the value of b. So we write a plus minus square root a plus b into a minus b plus b equals 2a. So that gives b equals 2a minus a minus plus square root of a plus b into a minus b. This will be b equals 2a minus a, that is a minus plus square root of a plus b into a minus b. So from this value of a and that of b, we conclude that the required numbers are a plus minus square root a plus b into a minus b. Friends, if you like this video, please click the like button, share this video with your classmates. Don't forget to subscribe this channel to get more videos of this type. Give your comments to make these videos better. You can suggest topics on which you want me to make videos. See you in the next video. Until then, keep watching Number Collage. Thank you.